OpenZeppelin have just released their first preliminary libraries for the Stellar Soroban smart contract platform. So we're going to dive in and take a look how to build a token contract using the OpenZeppelin libraries. So if we go into OpenZeppelin's GitHub account, there's a repository called Stellar Contracts, and in that we've got two directories, token fungible and utils. Utilities is just a pausable function at the moment, and that's actually incorporated into the token contract, but it's the token contract we want. So let's go into that. And what I can do is I can pull this token folder and I'm going to put that into my own repository here. That's this. So token fungible, we've got a source, that's not. I had to change the cargo.toml files, just because it was currently set up to be a workplace and I didn't want that. So this is the one that's in the token library. And this is the one that's in the root folder. So we've got a dependency here, which is a local dependency currently. Probably eventually they'll publish this as a crate, so you can just import it in the same way you would any other crate. But for the time being, because it's a preliminary release, we're going to kind of copy that in from GitHub and just use it locally. I'll put all this code on GitHub, so if you have any issues, you can find it there. So this gives us this token library, and this is a fungible token library, which we can import into our contracts to set up tokens. These are fungible tokens, which means they're SEP41, which is the equivalent to like ERC20. You can transfer, approve from, all that stuff. And one token is equal to any other token on the network. They're not unique like NFTs. And this is going to make it very easy for Soroban developers to kind of use tokens within their contracts, because we can just import one of these libraries and use it straight away. So let's go ahead and build our own token. So our code all lives in the source directory. We've got libfile, which is just the entry point which resolves contract and test. Then we've got test suite, which we'll get into, and the main contract file. Take some time to appreciate my beautiful little Zeppelin here. I drew that myself. It's been a long winter. So we then get into we're using the OpenZeppelin fungible token, and that is imported within our TOML library. We're also importing the Soroban SDK, pretty standard. And we've got the owner and the cap. These are the keys for a key value pair within the data store. So you aren't going to change these. You can do, but there's no real reason to change these. They're just going to be the keys that we store data in for the owner of the contract who's able to mint tokens, and the hard cap on the supply. So there's a limit on how much supply you can use. That's slightly different to the example that OpenZeppelin put out. When in OpenZeppelin's contract, they released like an example, and it didn't have a hard cap, and it allowed the owner to mint as many as they wanted. And there was like a distribution on the constructor as well. I've changed that slightly to make it more simple, I guess, and just more standardized. We've passed in an owner where the owner can mint as many as they want up to the cap, and they can mint them to any address they want. And we'll get into these functions in a sec. From here, we're simply setting the name of the coin and the ticker symbol, my coin and MC. And then we've got all the standard token functions here: balance, allowance, transfer, transfer from, approve, all the stuff that should be quite familiar if you've worked with tokens before. We've then got some burn functions and burn from, which requires approval, obviously. And that's just useful if anyone wants to destroy tokens. Maybe if the owner of the contract wants to burn some tokens, which allow them more cap to kind of increase the supply at a later date, they can do that. And then finally, we've got this mint function. We're making sure that the owner should be set. We are making sure that the owner is the person that's actually calling this contract. They can send the tokens to anyone, but it's only one address. Then that's the deployer of the contract, basically, that is allowed to actually mint new coins. And the cap should be set. And we're going to get the current total supply here. And we're going to check that the current total supply plus the amount that they want to mint isn't greater than the cap. If it does, it kind of errors with this custom error. And then if that's all okay, the owner can mint like new tokens to whoever they want up to the limit. I hope this demonstrates just how easy it is to kind of use these OpenZeppelin libraries, and in less than 100 lines of code, most of which is my little comments at the top, you can create your own token. You can set up everything you need to set up within that, and you've got a fully functional digital asset right there. Let's go ahead and deploy it on the network, and we'll kind of have a play with it and make sure it all works. So to deploy this, I'm using Windows Subsystem for Linux. You can download this online if you're using a Windows machine. You probably can do it on Windows now, but I just prefer using Linux for anything Rust-based. Let's kind of make this a little bit bigger so you can see what I'm doing. And then we're going to CD into the mount directory. So we're basically kind of changing the directory back to the Windows hard drive. Then I'm going to find my repository. So I've already got Rust installed here. So the first thing I'm going to do is try cargo build. Cargo is like the package manager for Rust, and we're just kind of building up the dependencies here. Okay, that's built. Let's run cargo test. Well, let's run in the test. So I'll just show you the test file. This is a direct copy of the one that OpenZeppelin provided in their examples. I've just removed some of the contracts. They had a pausable function, so you could pause the contract, which I didn't want in there. I wanted it to be more permissionless, so I removed all that from the contract and the test file. There we go, all 5 tests have passed. You can tell this isn't live coding. Right, the next job is to install the Stellar client. I've already got this installed, but if you didn't, you would do that with this command. Then we set up keys. So if we run Stellar keys, you can see we've got a bunch of options here to add, generate keys. I've already got an address set up under the name James. This is my address. Now, we're going to need some testnet tokens for this, and this is really simple. One of the best things about Stellar for developers, I just search my tutorial. I just get into my tutorial, find the link. It's just this friendbot stellar.org. So it's just a link, friendbot.stellar.org, !addr equals, and you just paste your address on the end, and it sends you testnet tokens. It's a beautiful, elegant, wonderful thing. So we've got an address set up, we've got some funds in there. Let's go ahead and add a target. So we're going to be assembling this to WebAssembly. So cargo build, target, WASM32, unknown. I'll put a link to the full tutorial in the description as well, so if you want to go through the code line by line, you can. Now that's all done, we're going to go ahead and deploy the contract. So Stellar contract deploy, set the target to WebAssembly, then the source is the key address that we're going to use to pay for the deployment costs, the transaction fees, network set to testnet, the owner is that same address, the deployer. I'm going to set a cap of 1 million tokens, so that the hard limit supply for this token contract is 1 million. You can never have any more than that many tokens in existence. Let's go ahead and deploy that. Boom, we got a token contract. So this CBC here is a token contract. We haven't currently got any tokens in our contract, so next thing we want to do is invoke mint. Because I'm doing this from the same address, I have approval to mint because I'm the owner of the contract. So I'm going to mint, say, 10,000 tokens. If I call balance, just check the balance function. It is account. So I'm going to check the balance of this account now. It should return 10,000. Let's remove this. Don't want to give it any clues. And yeah, we've got 10,000 tokens in. Now let's try one more thing. Let's try and mint too many tokens for more than we should be allowed. And we get this error, transaction simulation failed. That's perfect. That's exactly what we want. So we deployed this token contract. It's working as expected, and OpenZeppelin have done all the hard work for us. So thank you very much for that, guys. This is obviously a massive win for the Stellar ecosystem. The OpenZeppelin libraries are the most widely used libraries in the world for blockchain developers. And they've got a 2-year partnership now with the Stellar Development Foundation, which are going to be creating token contracts, utilities, cryptographic functions, all the kind of raw essentials that we need as blockchain developers to build out our tools. What it means is that all the simple things are going to be done for us, which is going to allow us to focus on building out the logic for our individual decentralized applications. As part of this partnership, OpenZeppelin also going to be doing security audits on the code, so we're going to have a library of audited code. We're not quite there yet. The code that's been released currently is just preliminary code. It's been put out there for feedback, basically. It's not the finalized version. It hasn't been audited by the independent security auditing team. So bear that in mind if you are going to be working with it. It's probably not quite fit for production use yet, but it's as good as anything else that I've seen. And it's going to be the first step on a 2-year journey to getting these templates and libraries in place so that blockchain developers can just plug into this and utilize different resources for their smart contracts. The last thing I want to do is just publish this on GitHub. So I'm going to go to GitHub desktop here. Let's have a little look at this. Can't find DeepSeek anywhere. Oh, that's fine. Let's add a new repository. choose the local path as Soroban Open Zeppelin token, select folder, initialize this for a README. I also want to add the correct git ignore for Rust, license MIT, create a repository. Commit all this code and publish it on GitHub. We go into GitHub, repositories. And there we go, all the code's there, including my beautiful little Zeppelin. I hope you found this video useful. If you want to find out more about building on Soroban, and there's some resources linked to in the description. All the code you've seen today is open source, and there's a full tutorial on my blog. Thank you for watching.